I'm an engineer currently working in Internet. My experience is around 1 year. Uh, my task is to build an AI-powered pharmaceutical customer complaint management system. Before starting with the demo, well, let's have a brief introduction about what is the main agenda of the this project, this task. In pharmaceutical quality management, the incoming complaints arrive as an unstructured text such as emails, call logs, PDFs, and etc. Manually reviewing them and categorizing them and will be the hectic task to the person who is reviewing it. So that we have come to the solution where our system solves this by the introducing a dual system AI Copilot interface that automatically parses the complaints, what do you say, extracted text, extracted structured metadata, runs the root cause risk assessments, generates formal plain text QMS summarizations. In brief, in simple words, we can tell this is a AI complaint agent where users will paste a random with a messy complaint, and AI will be segregating them and sorting out them with the sorting out them and saves in the database. Right. Let's have the demo. I have already taken the a small description of the complaint where this is a randomly mentions all the messy data which includes the date, branch, etc. Once I give it to the AI, AI starts thinking about it and it starts the parsing the text. Let's see, let's wait for the output. Here we go. Here we go. It passed all the data which by the prompt given by the user. It successfully passed this and extracted all the necessary data with the given prompt. Here we can see here we can see this sensitivity evaluation where it what do you say? It calculates the emergency, which will be categorized by three terms: critical, major, or normal. And this is the overall description of the given extracted parsing data, where it will be extracting with the summary of product name and branch, category, and etc. Here is the recommended next step where the use what the if it's an emergency critical situation or any kind of situation, what the customer or the user should do next after giving this after giving it. Let's move to the second procedure where the fallback. When user gives a fallback, like he wants to make any corrections in the in a extracted complaint called customer complaint. Then we will give it to the AI again without any typing, without any prompting. Here we are saving the customer's time along with the user's time. We can see here it has changed the number and expiry date, as we can see here. Before it used to be a different number. Before it used to be 8821, and now it changed it. In this way, we are using the AI Copilot, which will be saving the customer's time along with the along along we have to use the AI more efficiently. And coming to the we have another last feature called parsing with the PDF or etc. I have taken a industry standard means normal sample pharmaceutical customer PDF. Once we give it, it directly uploads it, which has all the details as simple. We can see here. Here we have changed the Apollo Pharmacy Hyderabad. This data completely has the another sample data, which completely changed here everything. Here is he changed the expiry date and the manufacturing unit. Here is the complaint description, and here is sensitivity evaluation where it describes what is the risk assessment and what is the next step we have to take care. This is a demo, and coming to the orchestration. Here is a simple workflow of the flow diagram of the project where I have used a read plus react plus redux UI for the UI front-end web app and the REST API JSON fast API backend server where when user sends a prompt it from the backend it from sorry from the front end it is sent to the backend and from the backend it sends to the land graph where it interacts with the OpenAI, which we are using the graph model 70p parameter. It sends back to the land graph to backend, and from the database it saves to the database. And 1 second, coming to the database, uh, when user commits to the it will be successfully saved, and you can see here. Here is the saved field. These were the fields where I tested before, and these are the newly entered field. This and it is directly saved in the Postgres. We can see it here. Here we go. It just now added here. It is directly saved in the Postgres. I will explain the schema and the post structure right now. Here is the code frame where I have used the backend and the LangGraph agent and the front end, which will be easy to the reviewer to clone the complete code at a time. Coming to the land graph, at the core of our AI processing engine is land graph, a stateful orchestration framework designed for the multiple AI step workflow rather than running a simple monolithic LLM prompts. Uh, we model the complaint intakes lifecycle as a state machine graph. Each incoming request passes through a sequence of four sequential nodes which will be the which will be critical in this program where each node updates specific state key before handling of the context to the next step. I have mainly there are mainly like extracting structure and preparing the summary and risk assessment and the recommendation of next actions. These are the main node pipelines where they play as a main for with using the LangGraph and the communicating with the node. Coming to the extracting system, where it passes eight structured parameters like customer, product name, batch name, manufacturing date, expiry date, and etc. This will be considered parsed, and the complete coming to the generating summary, it will be generating the complete summary of the parsed data, where what is the data, what is the required description, complete QMS description, and the risk assessment node, it evaluates the health hazard, where I can show you the code. This this is the land graph code. Uh, risk assessment will be considered as the major, minor, critical. And the next step is considered as the what do you say recommended standard operation procedure. Next step where where it will be considering the criteria based, and it will be suggesting what is the next step to be done. And front end is completely used with the React and Redux toolkit. For the interface, use a model split screen layout. The left panel, where the left panel displays auto-populated complaint field. QA specialist can review or the manually override any extracted value. Where the right panel is the AI Copilot chat provides the chat interface where users can paste raw text, complaint text, or upload PDF or document or issue follow. Uh, this is this is a where I have kept the mode as a theme as a light theme, and I have explained the procedure how it works and how it is used. Coming to Yeah, here in this task, the key architecture and technical decisions at the state precise field updates by parsing current form data back to the backend, or AI performs surgical field updates during the follow-up prompt sorry, uh, following prompt without resetting the rest of the form. That means when we the user can change the field without any manual editing with just a one prompt and plain text output enforcement. With a just a manual message text, we can completely autofill the fields without any involvement in manual texting. This is all about my task. And moreover, I have set up the Docker file also where it will be easy to open. However, this is my EME file. This is the front-end EME, and this is the Grok API key I am using for the Grok API key for which I am using it. Here is the model Llama 3.37B versatile as mentioned in the task. This is all about my project. And yeah, coming to the database. These are the database fields I have uh, mentioned where this all will be stored. We have it stored in Postgres, as I showed in earlier. Here are the fields are stored where we every field will be stored safely and securely. Yeah, this is all about my project, and thank you. Looking forward for any upgrades or any suggestions. Hope I did well. Thank you.